ladies and gentlemen, boys and girls. My name is Mr. Do and science is my business. Well, welcome to Mr. Do Science World, and today we're going to talk about momentum. Alright, so we're going to look at momentum, and then let's begin by looking at the definition of momentum. So what is momentum? Momentum is a product of mass and the vertical velocity, or the linear velocity of the body. Right. So when we look at the momentum, we are defining momentum to be a product of mass and the linear velocity of the object. That simply implies that P, as in momentum, okay, we use P to represent momentum. So we can say that momentum is simply mass times the velocity, where m is the mass and v is the velocity. So if you want to look for the unit in which momentum is measured, what is mass measured? Mass is measured in kilograms, and the velocity is measured in in meters, okay, per second. So we can say that the unit of momentum is kilogram meters per seconds. All right, so kilogram meters per seconds becomes the unit. All right, so since velocity is a vector quantity, what we have to understand is that momentum is also a vector quantity, and the momentum will always be in the direction in which the velocity or the vector velocity is going. So the momentum is always in the same direction as the vector velocity. All right. Now let's check it and see. If we have defined momentum by this, what does that mean? If an object is at rest, if an object happens to be at rest, are we going to say the object is having a momentum or the object is not having a momentum? Well, and you can see that as an ordinary person or to the layman point of view, they will tell you straight away that yes, the object have no momentum. But a physicist will tell you that it may be. That is, it may have momentum or not have momentum, depending on the situation that we're going to look at. And we're going to dive into that, and then you will understand that shortly what we mean by that. All right. Let's then look at what we mean by impulse, which work concurrently with the momentum. So when we say impulse, what we mean? An impulse is simply equal to change in momentum of an object. So if I have a change in momentum, anytime that the momentum of an object is moving from one place to another, there will definitely be a change in momentum. Let's say that the object moves from point A to point B. Okay, moving from point A to point B, there is going to be a change in momentum. And because there will be a change in momentum, this change in momentum is what we refer to as as the impulse. So change in momentum is simply the impulse of an object. And that means that we can say that impulse is simply equal to change in momentum. And what is the momentum? Momentum is mass times velocity. So we can say that impulse is simply mv final minus mv initial, and that is the change in momentum. On the other hand, we can also say that impulse is equal to the product of a force and the time taken by the force to act on that particular body or that particular object. So we can say that momentum is equals to force times times time. All right, or change in time. So this becomes our impulse. And if this is impulse and this is impulse, then we can simply come out to say something about the impulse, and we can define that in terms of in terms of a force and time, or we can define that in terms of change in momentum. All right. Now, how did we come about this impulse to say that is equals to change in momentum? Well, let's look at Newton's second law and momentum. We're going to look at Newton's second law and momentum together and see how we came about the impulse. Right. From Newton's second law, we know that F is equals to ma, that is F net is equals to ma. And what is the a? A is acceleration. And what is acceleration? Acceleration is the what? Is the rate of change of what? Velocity. That means that acceleration is simply what? V final minus what? V initial over what? Change in t. If I go back here and substitute that into the first equation here, call this equation 1 and call this equation 2. Let's substitute 2 into 1. Then F net is going to be m multiplied by F what? Mf minus what? Vf minus what? Vi divided by what? The t, or change in t, whichever. Okay, let me put change in t there. If I have it this way, what does this mean? This simply implies that what? F net multiplied by change in t is equals to what? F mvf minus what? mvi. What is mvf minus mvi? It is what? It is change in what? Momentum. And what is this? What is the F net multiplied by what? The time. It is the what? It is the impulse. That is why we said impulse is simply what? The what? The change in what? In momentum. So this is where the what? We got that definition from it. That's the reason why we are saying that what? Change in momentum can be the mass multiplied by the what? The change in what? In velocity. Or we can say that what? The impulse, the change in momentum is also equal to what? The F net multiplied by what? The change in time, which is the same as the what? As the impulse. So this is very important that we need to know this. This is very important. We have to keep this in mind and know that these can work what? Together. So this represents impulse. At the same time, this is also representing what? Impulse. This represents change in momentum, and at the same time, this also represents what? Impulse. So if we are given the mass and velocity, we can find the impulse. And if you are given the what? The force and what? The time, we can also find the what? We can also find the impulse. So that is how we came about what? The impulse equation. Alright, so we can see that whenever we are given a question and we want to calculate for the impulse, we can calculate the impulse if you are given the force and then the time. If you are given velocity and mass, we can also equally calculate for what? Impulse. What about if we are given what? Graph. So let's see. Graphing impulse. Right. Let's look at graphing impulse. We can also calculate for the impulse under what? Force versus time what? Graph. So if I have any graph, let's say like this, and our force is here, and then we have time here. Time is in seconds, the force is in newtons. So, and we want to find the what? The graph. Let's say we plot a graph, and we are seeing a graph like this, right? We can easily calculate for what? For the impulse here. How do we calculate for the impulse under the graph like this? We will calculate for the impulse by calculating for the what? Area under the graph. So if you look at this, this is the graph, okay? Because this is the what? The Cartesian plane. The y-axis and the x-axis, which the x is representing the time, and then what? The y is representing the what? The force. So if we have these and we want to calculate for the what? The impulse, we only just have to look at what? This shape. And what is this shape? This is what? A triangle. So if I want to find the impulse, I can simply say that the impulse is equal to what? Is equal to the area under the graph. And what is that area? If you look at this shape is what? It's a triangle. So if it is a triangle, then I can just say it is what? Half base times what? Times the height. And that will also aid me in calculating for what? For the what? For the impulse. So whenever you are given a graph and you want to calculate for the impulse, you can calculate for the impulse by knowing the what? The shape of the graph. And then you calculate the area under that particular graph. And when you do that, you'll be able to do what? To find the what? The impulse. Alright, now let's forge ahead and see something. We have said from the beginning by saying that what? Our velocity is what? It's a vector. Okay, because we know that velocity is a vector quantity. And we also established from the fact that since we are having mass multiplied by v, if you multiply a vector by what? By a scalar, at the end of the day, your product is going to be what? A vector. So therefore, we are saying that momentum is also what? Is also a vector quantity. And if momentum is also a vector quantity, and we use that also to determine the what? Our impulse, then we can equally say that impulse is also what? A vector quantity. Why? Because if you look at impulse, we said impulse is what? Is force multiplied by time. The time is a scalar, the force is a vector, so we should have what? A vector. And then if you look at it from in terms of change in momentum, we are saying that it is what? The change, it is mass times what? Change in v. The v is what? Is a vector. Therefore, if you multiply by a scalar, we should still have what? A vector. So we have established from this point to say that velocity is a vector quantity, momentum is a vector quantity, and impulse is also what? A vector quantity. Let's try and look at some questions from this junction. Alright, so let's see the first question. Alright, so let's look at the first question. The question says, a small block of mass m is equals to 0.070 kg. Initially at rest, is struck by an impulsive force F of duration 10 milliseconds, whose strength varies with what? With time, according to the following graphs. So now the graph is what is given here. So you can see the graph. Let's look at the graph here. There. That's the graph that we have there. And if you look at this graph, you can see that the graph is like giving us like kind of a trapezoid. Okay. All right. So if I look at that from that point, I can also divide the graph into what? Into three parts. So let's see from here. Let me try to sketch this graph here for you to get what I mean. Straightforward from here. Okay. And we can see here is 20. Okay, and on this side, if you trace it down, I'm getting 2 there. If you trace this one down here, here is giving us 6, and here is 10. So let's just take this from what we have there. Let's look at that to do the calculation and see. Right. And if I look at this, the first question, what we want to look out for is that what is the resultant speed of the block? What is the resultant speed of the block? That is what we want to find out. Well, if we want to find the speed of the block, and we are given this, here is a force, and this is what? Time. So this is force versus time graph. So the first thing I need to do is that I can find a what? I can find the impulse from here, because I'm given force and time. So I can find the impulse. And if I want to find an impulse, what do I say? I say that the impulse is just simply equals what? The area under the graph. And if I look at this shape, as I said, this is a trapezoid. But if I don't want to look at it from that point, I want to just look at this, and I will look at it from 3 different versions. So there should be 1, 2, 3. So I have 3 different shapes. And shape 1 is what? It's a triangle. Shape 2 is a rectangle. Shape 3 is also a triangle. And if I look at this, I can see the base here is what? Is 2. The base here will be what? Will be 4. And the base here is also what? Is also 4. The height is what? Is 20. This is also 20. Okay. And I know, so here is also 4. So I can simply just do the calculation there. So I can say this is equals to the area of the triangle, the first triangle, triangle 1, which is half times base times height, okay, for 1, 1, plus the what? The rectangle, which is what? The length times the breadth, plus the what? Half times the base of 3 multiplied by the height of 3. And then we can find that value. But one thing we have to take note of is that there should be some kind of a unit conversion, because this was given as what? Milliseconds. So now I'm going to convert this into what? Into seconds by dividing the numbers that I have by what? By 1,000. And once I do that, this is going to give me impulse is equals to half multiplied by the base is 4. 4 divided by 1,000 is 0.004. Okay, multiplied by the height, which is 20, plus the length, which is what? Which is 4. So that's 0.004 multiplied by the what? The height, the base, which is what? Which is 20. Okay, and then I am going to be plus half multiplied by the base here, which is 4, so 0.004 times the what? The height, which is what? 20. Quickly, and then let's solve this and see. So let's punch that into our calculator. If I do that, what I'm going to have what? 0.5 multiplied by 0.004. Okay, multiplied by 20 plus another bracket 0.004 multiplied by 20 plus I have another bracket open 0.5 multiplied by 0.04 sorry 0.004 okay multiplied by 20 and then okay. So if we do this straight away from here, I think here this is 2, on this side this is 2, okay, and this is 4. So this should be 0.02 here, so that at the end I should have 0.14, right? 0.14 what? Newton seconds. All right, good. So here is 2, here is 4, and this is 4. So if that is 2, I put 2 in there. That becomes 0.02. Multiply that. Okay. I'll get 0.14 what? Newton seconds. This is Newton seconds. Let me use a different color for that to differentiate it from each other. So this is Newton seconds. All right. Good. If I don't want to solve it by this way, I know the shape is what? It's a trapezium or a trapezoid, and therefore I can just simply make use of the formula for a trapezoid, and I will say that what? The impulse is now equals to the area under the graph, and that is going to be what? Trapezoid is, the formula is half into a plus b multiplied by what? The height, and this is 1/2 multiplied by here. Now a is going to be just here, which is 4, and that's 0.004 plus what? Plus the base, which is here, and that is 10. So that will be 0.010. Okay, all right, and then we will multiply that by the height, which is what? 20, and then let's see what we're going to have also from here. All right, so if I do that as well, I am having 0.5. which is multiplied by 0.004, okay, plus 0.01, okay, and then I multiply that by 20, and straight away we are getting the same thing again, which is what? 0.14 what? And the unit is Newton second. So this also becomes the what? The impulse as well. So we can use either. Once you know the shape and you know the right formula to use for the shape, you can just straight away use that, and then you calculate it straight away like this, or you divide the what? The shape into what? Into different shapes, and then you then add the formulas together, do the substitution, and solve for what? For the value. Good. We have solved for the impulse. That is not what we are looking for, because the question wants us to look for what? The speed of the block. So if I want to look for the speed of the block, after I have been able to calculate for the impulse, I know that there is a relationship between impulse and what? And change in momentum. So I can just simply say that what? Impulse is equals to change in momentum. And if impulse is equals to change in momentum, and I have calculated for the impulse, which is 0.14, what is the change in momentum? It is m into v final minus what? V initial. And where was the block? It said a small block of mass d is initially at rest. So that means that the initial velocity is what? Is 0, because the block was initially at rest. And now we need to find the what? The final velocity. So straight away, the mass was given to us to be 0.070. Therefore, we say 0.14 is equals to 0.070 into v final minus 0. And then we will solve for what? The v final. So to solve for v final from here, let's see what we're going to have. Once I am solving for v final, I am here is 0, so I'm going to divide through. So I'll say v final is now equals to 0.14 divided by 0.070. And what is my v final? Okay, so I have 0.14 divided by 0.070. And then we are getting 2 meters per second. And that becomes the what? The velocity with which the block will be what? Will be moving. Let's look at the next one. The next question says, a 25 kg cat jumps out of a window when it's 35 meters above the ground. And the first question says, how fast is she falling when she reaches the ground level? How fast is she falling when she reaches the ground level? So here, if you look at it, the cat is falling from a window. The cat is not thrown from a window. It's falling from a window. So if it is falling from a window, it's just like the cat is dropped from what? From a window. So our initial velocity is going to be what? It's going to be 0. And once you are able to detect that, then we know what? The mass. The mass is given as what? As 25 kg. And we know that what? The height is also given to us as what? The height of the building was given to us as, or the height of the window is given to us as what? As 35 meters above the ground level. So what I need to do straight away, if this is my window, okay, let's say this is the window here, and the height of the window is what? Is 35 meters. Right, and then the cat is falling on that window, coming down there. What I need to do straight away, I know that my initial velocity is 0. My final velocity is not known. That is what is yet to be determined. This object is falling through vertically, and therefore we can say it is undergoing what? A projectile motion. So we can talk about the acceleration with which it is going to be falling, and we can see it will fall with what? With an acceleration of 9.8 meters per second squared. Then we can make use of equations of motion and solve this problem. So how do we solve? We can just say that, okay, the right equation of motion is Vf squared is equals to Vi squared plus 2g change in what? In y. Because it's in the vertical direction, so change in y. And what is the V final? It's not yet known. What is the V initial? The V initial is 0, so therefore it is automatically just this. And let's just now do the substitution and solve. So if I do that, I can say my V final is just the square root of 2 multiplied by 9.8 multiplied by 35. Alright. So here it's like I'm taking my downward motion to be positive. That is why I'm taking my G to be what? Positive 9.8. And now let's use the calculator and see what we're going to get. If I do that, I'm having 2 multiplied by 9.8 multiplied by what? 35. And what am I getting? I am getting what? I am getting 26.19. I'm leaving it in 2 decimals. So 26.19 what? Meters per second. If I want to leave it in correct sig fig, then it should be in 2 sig fig, because this is 2, this is 2. So then my answer will become what? 26. So if I leave it in 2 sig fig, it is what? If I leave it in the 2 decimal places, it's 26.19 what? Meters per second. I can also leave it, this is for 2 decimal places. Alright. If I want to leave it in the correct sig fig, then it is going to be what? 26 meters per second. and this is in the what? Is in 2 sig fig. 2 sig fig. 2 sig fig. So whichever way you want, right? So you can leave it in the correct sig fig, which is always the right way in terms of what? Science. But there are other curriculums that always encourage students to leave their answers in what? In 2 decimal places. So that is why I always leave it in 2 decimal places. But if you want it in the correct sig fig, that is the correct sig fig. Okay, let's move on. What is the next question? The next question says, she lands on her feet on an air-filled mattress, coming to rest in 0.78 seconds. What average force does she feel when coming to rest? Alright, so let's see what we are given here. Time is given again, so we can see that our time is given. Maybe I will need this value, so I don't want to clean it off. So let's go. Time is given, and the time is given as 0.78 seconds, and we know of the mass, which is given to us as 25 kg, and we have calculated and know the velocity initial is 0 meters per second. Final velocity is given to us as 26.19, okay, 26.19 meters per second. Okay, and now we want to calculate for, or we want to find the average force that she will use to land when she's at rest. Alright, so we want to find a force. So if I want to find a force, I can just simply say that I will state what? F net being equals to what? Change in what? F net being equals to MA, okay, divided by the time. So let's look at it from, sorry. Let me look at it from the point where we look at the momentum and Newton's second law. And let me just state it straight away. So we can say that our F net multiplied by change in t is equals to what? Change in momentum, right? Okay, so change in momentum, which is this. Good. The mass is common, so I don't want to expand it and put the mass twice. I just want to do the substitution straight away and get my answer. What is not known here is the what? Is the force which we are looking for. So that makes life very easy for me. So I can just simply say that F net is simply equals to what? Is simply equals to M into V final minus V initial divided by what? Change in T. And let's do substitution. The mass is given as 25. The final velocity is 26.19. I got 26.1916. So let me use the actual value because I don't want to use the approximated value. This, okay, minus what? Minus 0. Initial is 0 divided by the time, and my time is given to me as 0.78. Good. And now let's punch the calculator and let's see what we're going to have as our answer to that particular problem. Right, so if I do that, we are having 25 multiplied by 26.1916. Right, so we multiply that and then we are dividing that by 0.78. And once we do this, our answer, which is the F net, is now going to be what? 839.47. Again, guys, if I want to leave it in the correct sig fig, this is 2 sig fig, this is 2 sig fig, and this is 6 sig fig. So my answer should be in what? In 2 sig fig here. I'm multiplying and I'm dividing, so we should have it for multiplication and division. So I expect that, okay, at the end of the day, if I leave it in the correct sig fig, then we are going to have this is newtons. It's a force. So correct sig that we are going to have here is that it's going to have 84 0, because now we will leave it in what? In 2 sig. So we're going to have 84 0 what? Newtons. And that will be the correct what? Sig. If you leave it in 2 decimal places, that is it. 2 decimal places and then correct sig, which is 2 sig. Alright, let's look at the next question for that problem. The next question here, let's check it and see. It says, what if she had landed instead on the ground and come to rest in 7.8 times 10 to the power negative 3 seconds? The first one, she landed on what? On a mattress. But this time around, the question is asking if she landed on the bare floor. We want to find a what? It said, what if she had landed instead on the ground and come to what? Come to rest in 7.8 multiplied by 10 to the power negative 3 what? Seconds. So if you look at this one now, from here, we are still going to look for what? To look for the time again. The time is what we are looking for. And if we are looking for the time in this situation, but this time around we are given what? Sorry, we are looking for the force. And we are given the time. The time has changed again in terms of what? Value, which is now what? 7.8 times 10 to the power negative 3. So let's try and put in the values that we know and then solve for the problem again. Right. We can see time is given 7.8 times 10 to the power negative 3 seconds. And then we know the final velocity was given to us by calculation as 26.1916 meters per second. And then the initial is 0. Right. And what we want is we want to find the force from here. So we're going to make use of the same formula that we did there, and that will become F net is equals to M into V final minus V initial divided by what? Change in T. And what is the M? The mass was given to us as 0.78, right? And then the velocity is now 26.1916 minus 0, and we are dividing by the time now, which is 7.8 multiplied by 10 to the power negative 3. And let's see what we are going to have for that. Okay. So the time is now 7.8 multiplied by 10 exponent negative 3. Right. Every other thing remains the same. Oh, sorry. The mass is given as 25. Sorry, not this. So the mass is 25. Yeah. So every other thing remains the same. Mass is 25. If I do this, well, let's see what we are getting. We are getting 83947.4359. And we are going to leave our answer in the correct sig. So if I have to leave it in the correct sig, what is the correct sig here? I will leave it first in 2 decimals. So in 2 decimals, it's going to be F net. It's going to be 44 newtons. That is in terms of what? 2 decimal places. If I am leaving it in the correct sig, then we can see that this is 2 sig. Okay, this is 2, so my answer must be 2. So that will be 840 multiplied by 10. I move back the 1, 2, 3, and 4. So then we are going to have 8. This is 1, 2, 3, 4. Okay, right, good. So this is 8.4. Okay, 0 multiplied by 10 to the power of what? To the power of 4. And that must be in terms of what? In newtons, because it's a force. Right, so this also is in terms of what? The correct sig. If I leave it in the correct sig, I'm getting this. If I leave it in the what? In 2 decimal places, I am getting that. Which this is just exactly this in terms of what? Approximation. All right, okay. Let's move on and see the next thing. If you look at the calculation that we just did right now, you can see that there are two different times that were given to us, and the other values were the same, and we tried to do the calculations for that. If you check it very well, you can see that if you are increasing the what? The slowing down time, okay, or when as the cat was was moving down, if you are increasing the slowing down time, what you are doing is that you are reducing the what? The acceleration and the what? And the force. And once you are reducing or decreasing the acceleration and the force, ideally, what are you doing? You are trying to prevent what? You are trying to prevent what? Injury. And this is what is being employed by the what? The cramp zones and what? And the airbags, which are found in what? In cars. That is the application of the what? Of the impulse in there. So if you look at that, by saying this, if I state this formula that we have here, change in V, okay, over change in time. If you look at this, you can see that if let's put it that way, change in V. You can see that if this is increasing, because this and this are inversely related, so automatically once this is what? Increasing, then this will be what? Will be decreasing. So that is what we are saying. And if you are decreasing the force, then the impact is now what? It's now decreasing. So in that case, you are not going to have what? More injury. You are preventing the person from what? Sustaining more injury. And that's the reason why you see boxers. When boxers when they come into the ring, they put on gloves. Why are they putting on the gloves? They are putting on gloves in order to reduce what? The force. Because when the gloves are there against their fix, what is happening is that when you give a punch, the fix and the gloves between the person's face or the cheek that you are punching, there's a glove there, and that glove is what? Is increasing the time of contact. And as the time of contact is increasing, the force is what? Is decreasing. And if the force is decreasing, then injury is also what? Is also decreasing. Thank you very much for watching this video. And please, if you have not subscribed to our YouTube channel, please do subscribe to our YouTube channel. And then as you subscribe, please click on the notification bell so that anytime we release any new video, you'll be the first person to watch it. Please like our videos, share the videos, and then give comments. For these things are very important to us. Thank you. See you next time. All I want to say to you is that please keep on learning, for learning is life and life is learning. See you next time. Bye-bye.